So, good morning to everybody, and I believe that yesterday you had a good learning day. Today morning we will start with the sustainable energy technologies, and the objective of this GAN course is that to utilize the expertise or the knowledge which I can share with you with reference to sustainable energy systems, and then how we have to utilize the machine learning in managing, implementing, controlling sustainable energy technologies. Yesterday morning, I tried to give you one example of one of my project. That project, it was very interesting, and I believe that you might have enjoyed some description of that project, because that project is going to be very useful, especially taking into account our rural Indian conditions, because we know that in India there are a lot of people who are living below economic level and they do not have proper access to energy, and many people they are living in remote off grid areas, and it is our duty to help them to bring up back to the normal way. And for that we have seen through yesterday's project that how sustainable energy technologies can help them to have the energy access. Okay? So, it means that that project what we discussed yesterday is going to contribute effectively on sustainable development goal 7, clean energy access for all. So, today we will move forward, and today we will more focus on integration of renewable energy systems for hydrogen production. Okay. So, this is a very hot topic at this moment around the world, and Indian government has also agreed that they want to be the leader in green hydrogen production. You might have observed through media, through technical news also, all leading industrialists, they are trying to use this green hydrogen as an energy carrier and to export green hydrogen in the form of green ammonia around the world. So, this is a very interesting topic. So, first I will share with you a very small example of one of the project which I did in 2006 and 7 while working at University of Jyväskylä, Finland. Yesterday I was mentioning that I was working as a research director at the University of Jyväskylä, Finland, and there my responsibility was to develop master's program in renewable energy with 3 components: education, research and demonstration. Education, all of us we know that we need to develop the courses and we have to teach to the young generation. Research also we know that we have to do the work with upcoming technology, but the key component of that project, it was demonstration. It means that we have to integrate the local community through this research demonstration project, so that we can get the society integration in that. So, with reference to that, you can see that in early 2006 and 7, I worked on this solar hydrogen energy system. So, how this solar hydrogen energy system it works? Okay. This is a very interesting topic. We know that on yesterday also we discussed, and then when I will discuss all these things, then we will see that how we can use the machine learning for the controlling of such type of system. Yesterday we have seen that whenever we have the off grid system or any renewable energy system which is going to have intermittent renewable energy sources. This intermittent renewable energy sources, for example, solar photovoltaic, wind turbine, etc., they are going to be connected within the distributed energy network or within the small power system network. Sometime we will call it as a microgrid also. So, to overcome the intermittency of these renewable energy sources, in yesterday's lecture we had some discussion that we need to have appropriate energy storage. We know that battery bank can play the major role for the energy storage, but short term energy storage using battery bank is quite okay, but if we want to have the long term energy storage, then we need to utilize hydrogen as an energy carrier. I believe that many of you may be following the international development with reference to the upcoming technologies. You might have observed that all the leading countries, they are trying to move by utilizing hydrogen as an energy carrier, right. So, Indian government has also produced hydrogen economy document which says that India is planning to lead, okay, to produce the green hydrogen and to utilize that green hydrogen in making green ammonia and to supply it. So, how this green hydrogen is going to come, that we are going to discuss through this project which I did long back, let us say 20 years before. So, in this project the idea was that when we have intermittent renewable energy sources, to overcome the intermittency of these renewable energy sources, we need to find out appropriate energy storage. To get this appropriate energy storage, either we can use the battery bank or we can use hydrogen as an energy carrier also. So, if suppose we are going to utilize hydrogen as an energy carrier, then how such system need to develop. Okay. I was planning to use the document camera, but then I am thinking like if I use the document camera, then this picture will go out. Okay. So, maybe I will try to use the board, okay, then it will be quite better, okay, because we do not have the dual or triple display. Okay. So, maybe in the next lecture we will try to find out how we can do that one. So, now here if you say we have renewable energy sources, means sustainable energy sources. These sustainable energy sources output is going to be intermittent power versus time. So, this intermittency we need to overcome. To overcome this intermittency, we need the energy storage. And when we want to have this energy storage, what I mentioned that either we can use the battery bank or we can use hydrogen as an energy carrier also. Both energy storage are based on electrochemical energy conversion. Now, when we have to store the energy, so when we are getting the intermittent renewable energy, in this case it is the wind turbine and the solar photovoltaic system. So, this output which is intermittent in the nature, and sometime this system is going to be grid connected also. So, to overcome the intermittency of this sources with the objective of storing the energy in the form of electrolytic hydrogen, we need to have appropriate power conditioning devices here. So, this appropriate power conditioning devices, I believe that most of you are from the electronics background, am I right? Right. So, you know that how we can develop the power conditioning devices to integrate the wind turbine or the solar photovoltaic system together. If we consider the solar photovoltaic system here, so this power conditioning devices, it is going to be having the capability to extract the power at the maximum power point. Is it okay? I believe that you might have already studied about the maximum power point tracking of solar photovoltaic panels, and for that we need to develop the DC-DC converter. So, here you can see that within the renewable energy sources, when we have the solar photovoltaic system here, and we know that the output from this solar photovoltaic system is going to be depending on incident solar radiation under different conditions, right. So, our objective is that to operate the photovoltaic on this point, that is a maximum power point tracking mechanism. So, here I can say that it is a MPPT mechanism which is going to be based on DC-DC converter here. Okay. So, this DC-DC converter which is going to be required to integrate this solar photovoltaic system here is going to be very important. So, here you can see that when we are talking about sustainable energy technologies, how you can utilize your electronics background in developing a specific component which is required to integrate the solar photovoltaic system by using DC-DC converter to operate at the maximum power point. Okay. So, here we have that point. So, here you can see that how you can utilize your technical knowledge about that one. Similarly, for the wind turbine also, we know that wind turbine we need to connect here under the renewable energy sources here. So, this wind turbine is again depending on which type of generator we are using there. So, in small capacity condition, if we are not talking about very high capacity condition, so this may be 3-phase permanent magnet synchronous generator. Is it okay? So, those who are having some of the electrical engineering background or might have did some course on electrical machines may be aware about that one. Now, when we are talking about the wind turbine 3-phase permanent magnet synchronous generator, so how the output will be there? The output will be variable voltage, variable frequency. So, this variable voltage, variable frequency which we cannot feed into the system, because it is not at a proper reference level. So, now here your electronics knowledge will come into picture when we have the output variable voltage, variable frequency. So, basically that output is AC, and that AC we need to convert into the DC at appropriate voltage. So, here you can utilize your electronics background on developing this power conditioning devices or understanding the operation of this power conditioning devices, which is required to connect the wind turbine with this system, right, by using this AC to DC converter. And then we know that similarly for the solar photovoltaic system, we have the maximum power point tracking mechanism. In the same case, we will also need to operate this system for operating at maximum power point of wind turbine operating characteristics. So, to operate this wind turbine at the maximum power point, considering wind power characteristics, we need to have appropriate knowledge on developing that power conditioning device, which can help us to operate this wind turbine at the maximum power point. So, it means that by utilizing the electronics background, we can operate the solar photovoltaic and the wind turbine by using the appropriate power conditioning devices and controlling them to at the maximum power point or to extract the maximum power from these sources. Now, I will go in some detail after some time. After that, our objective is to store the energy in the form of electrolytic hydrogen, okay, because we want to integrate all sustainable energy technologies together. So, that is the objective of our course also. That is why the GAN or the Government of India funding agency, they approved this course. So, now after integrating these renewable energy sources to operate them at the maximum power point using this appropriate power conditioning devices. One device is for the wind solar photovoltaic system, that is to operate at the maximum power point DC-DC converter. Second, it is for the wind turbine. Here we have taken 3-phase permanent magnet synchronous generator, variable voltage, variable frequency output, that which we cannot feed. So, for that we need here to convert this AC to DC, and then when we have the DC output, from the photovoltaic as well as from the wind turbine here. So, that DC output, okay, is very important, because we have to convert that energy, excess energy, in the form of electrolytic hydrogen. Okay. So, most of you might have studied in your engineering chemistry course about the electrolysis process also. So, for the electrolysis process, we need to provide DC supply. That is why I did not mention about the AC thing. I mentioned only for the DC output from the both sources. So, that DC output have been provided to the electrolyzer here. When we are providing that DC output to the electrolyzer, okay, so this electrolyzer, there are different type of electrolyzers are available into the market. For example, alkaline electrolyzer, PAM electrolyzer, anion exchange membrane electrolyzer, solid oxide electrolyzer. Okay. Out of these electrolyzers, alkaline electrolyzer is a well established technology which have been used continuously from last 1 century, maybe I can say. So, we are in constant need of hydrogen, and there is going to be a big requirement of the hydrogen also. Okay. So, how it is going to be there, and why we need to have the hydrogen from the green or the clean energy sources. So, anyone can tell about this one? Because we are talking about to have sustainability within the system, and we want to reduce the greenhouse gas emission. Many developed countries, they have signed the agreement by 2050 they want to be the carbon neutral. India has also signed the agreement that by 2070 to be a carbon neutral. To become the carbon neutral, we have to reduce our dependency on hydrocarbon. Okay. So, at this moment, the hydrogen which we required for many applications is coming from natural gas reforming. Around or more than 95% hydrogen is coming from natural gas reforming. So, when we are doing the natural gas reforming, the CO2 is going to be emitted. So, it is not going to be the carbon neutral. And now, we have seen recently due to Russia-Ukraine war, there is a lot of geopolitical conflicts, especially with the supply or the natural gas supply. So, to avoid this geopolitical conflicts also, and to reduce the carbon emission, in place of hydrocarbon, we can use green hydrogen. So, the learning from this project is going to be very useful for understanding how the green hydrogen can be produced by using renewable energy sources. And you can see that I did this project in early 2000, which was funded by European Union Regional Development Fund in cooperation with regional industry at Finland. So, here when we are talking about this electrolyzer for producing the green hydrogen, we need to provide the DC supply. So, this DC supply from the wind turbine and the solar photovoltaic system, how we can get here, you can easily understand. But now, here considering the power electronics and the electronic component and the control system, we may need to control these power conditioning devices from the wind turbine as well as the solar photovoltaic system continuously by using PWM switching signals also. Okay. So, when we are using this PWM switching signals for controlling this AC to DC converter, DC DC converter, so we may need to develop this control algorithm based on the inputs which we are going to get from the wind turbine and the solar photovoltaic. It means that we should have the appropriate information about the incident wind speed on this wind turbine as well as information related to the incident to the solar photovoltaic solar radiation which are incident on the solar photovoltaic panels like that. Okay. So, now when we are providing this DC to the electrolyzer, when we are providing this DC power to the electrolyzer, and let us say in this case it was alkaline electrolyzer. So, alkaline electrolyzer always need constant power supply. It cannot operate under the intermittent power supply. That is why here either we may need to have another source to overcome the intermittency of this source. So, in this case the electric utility grid have been taken. So, when this alkaline electrolyzer it operates, right. So, it produces the green hydrogen because we are utilizing the green energy. So, when this hydrogen which is a byproduct from this electrolyzer and we are using alkaline electrolysis process. So, the hydrogen which we are going to get, it is already very pure, maybe 99.99% pure hydrogen. So, that pure hydrogen is basically as an energy carrier, and that hydrogen then going to be produced depending on the operating pressure of the electrolyzer. In this case it was the atmospheric pressure. So, here we are storing that hydrogen after doing the compression at a particular pressure. Is it okay? Are you able to understand? Now, here when we are talking about alkaline electrolysis process here, so this alkaline electrolysis process is again very important. I think most of you might have studied the engineering chemistry during your undergraduate courses also. We know that this alkaline electrochemical process needs proper operating temperature also, and of course, it will need proper electrolyte and as an input water also. So, when using that DC electrical energy which we received from this sustainable energy sources, we convert it into the hydrogen. Why we convert it into the hydrogen? Because hydrogen is having very high mass energy density compared to others. And when we are storing that energy in the form of hydrogen here, and this electrolyzer is producing the hydrogen at the atmospheric pressure, then we have to store that hydrogen either into the compressed form or metal hydride form or maybe in cryogenic form. Is it okay? So, if in most of the cases the hydrogen will be stored in the compressed form. Okay. We can store it into the metal hydride form maybe for the portable usage. If you want to store the hydrogen into the cryogenic form, then the temperature is going to be very low, around minus 273 degree centigrade. So, again we may need further energy for the cryogenic process also. So, compared to that, to store the energy in the form of compressed hydrogen is more practical, and for that the technology is available into the market. We can store that hydrogen up to 700 or 800 bar into the composite fiber tanks also. Okay. So, then when we are storing this energy here in the form of hydrogen, then we need to utilize it. So, in this case there were two options. One option was that to utilize that stored energy in the through the proton exchange membrane fuel cell for stationary application or maybe for automobile applications also. Okay. So, if we consider let us say stationary application, so on the top you can see that we have the electric load, and that electric load can be supplied by utilizing the electrical energy output from proton exchange membrane fuel cell. I believe that You may be aware that there are different type of fuel cells they are available, okay. But in this case, due to the purity of the hydrogen, proton exchange membrane cell, a membrane fuel cell, due to its lower capacity, can be a good candidate for stationary applications as well as small capacity automobile applications also. So, therefore, the stored energy in the form of electrolytic hydrogen have been utilized as a fuel to this proton exchange membrane fuel cell. When we are supplying that fuel to this proton exchange membrane fuel cell, so let us say this is a PAM fuel cell, and in this PAM fuel cell we are providing hydrogen as a fuel, and this hydrogen as a fuel, how we get? We got, let us say, as a green hydrogen, and this PAM fuel cell is again electrochemical device. To make the complete combustion or complete chemical process, we need to have oxidant also. So, this oxidant can be air or the oxygen also, and then this proton exchange membrane fuel cell, which is an electrochemical device, going to produce the DC electricity at a proper operating voltage, depending how many number of cells are there in the stack. So, when we are getting this DC output from this proton exchange membrane fuel cell, so this DC output is going to be at an appropriate voltage, which we cannot feed directly to any system. So, if that system is, let us say, DC system, so we may need here DC to DC converter, okay. And then if we have the AC load, then we need here DC to AC converter, and then we can fulfill this load. So, now here you can see that this proton exchange membrane fuel cell, in which we are utilizing hydrogen as a fuel, oxygen or air as the oxidant, and taking into account the operating condition of this fuel cell, we are producing the DC and putting as DC-DC converter, and then putting DC to AC converter, and we can supply the electrical load. So, here what I want to teach you, or what I want to share you the experience of working on this sustainable energy project, how we can integrate different sustainable energy technology for storing it in the form of electrolytic hydrogen, or maybe in short hydrogen as an energy carrier, and for that how we need to have different power conditioning devices integrated together. And then when we are going to get all this information and all these system components integrated together, then we are going to collect all the data here, and then I will explain you how we can use the machine learning techniques, right, for managing or controlling the operation of such type of system. Is it okay? Do you have any doubt or any question? Just feel free to ask, okay? So, here you can see when we are using the stored energy in the form of electrolytic hydrogen as a fuel to the proton exchange membrane fuel cell, we can supply to the stationary load as well as we can supply it to the car also or automobile also. Okay. Now, here I will tell you, when I was working at University of Jyväskylä, Finland, so in cooperation with the local technical college, the local technical college, it is just like a polytechnic basically, they help in developing a single passenger car. They built this car specially for this project, okay, in which we are using this hydrogen as a fuel. You can see that in early 2006 we worked, in early 2000 we worked on that one. So, this hydrogen at one point we stored into the compressed form, but at the second point we want to utilize that hydrogen as a fuel in this single passenger car. So, in that case, case of the single passenger car, we used metal hydride hydrogen storage tank. Okay. So, those I think in your basic chemistry, engineering chemistry, you might have already studied about metal hydride conversion system for storing the hydrogen. Okay. So, in place of here hydrogen gas compression and storage, in the second phase we used metal hydride storage tank, and that metal hydride storage tank, right, because its capacity is, it is going to be very portable. So, it is quite easy that portable metal hydride tank to use as a fuel in this single passenger car. So, this single passenger car specially it was developed for this project, and in this metal hydride hydrogen storage tank have been used, and that hydrogen has been supplied to this proton exchange membrane fuel cell. And you know, then proton exchange membrane fuel cell, it was producing the DC electricity. So, the DC traction motor it has been used in this single passenger car. Okay. So, here I mean if you open your eyes and try to understand that how these different technologies can be integrated together with what objective? With the objective is that we are trying to reduce the carbon emission. We are trying to move towards the zero carbon society. So, here you can see all renewable energy sources, they are carbon neutral. We are storing that in the form of we are storing the energy in the form of hydrogen. We are utilizing that hydrogen for within the automobile sector. So, the emission from this hydrogen fueled car is going to be pure water H2O, and that water quality is so pure we can even drink it. So, you see the overall objective is to make our system carbon neutral, and because I think all of you people are, including me, we are grown up and we always follow the news and everything, and technology development policies and everything. So, everywhere the objective is that we have to reduce the greenhouse gas emissions, and for that government they are developing different policies and like that. So, now hydrogen economy is also the key point for the discussion, and government is allocating lot of funding also for that one. So, here you can see that how the learning from this project can be utilized in achieving some of the objectives related to hydrogen economy. Okay. So, this is a very interesting project, and this project what I was mentioning that when I was working at University of Jyväskylä, Finland as a research director. So, this project it was under the category of demonstration of technology to the society, right. So, that the society should get integrated in the system. So, when we are producing the hydrogen and running the single passenger hydrogen fueled car within the community, okay. So, the people or the common public, they will get engaged with that one. Then we will get more public participation, public support, more funding also. And then this project also utilized for what purpose also? For education and research purpose also, because we have to train the next generation professionals also. So, many of the students, based on their different academic background and interest, they did their research work on different topics also. Some of the students, they did the work on electrolyzer characterization, modeling and analysis. Some of the students, they did the work on fuel cell characterization, modeling and analysis also. Some of the students who are having more electronics background, they worked on required power conditioning devices, how they operate, where we are going to have the fault, how we have to design and like that. And those who are having more interest in the control system. So, of course, we need to have the complete control system here, and when we have the control system, we are going to collect all the operating data here. So, we need to have control and data acquisition system. So, depending on that, some students they work on that also. So, here you can see that how the different disciplines are integrated together for this sustainable energy system with the focus on hydrogen as an energy carrier. Now, here I will tell you, this picture is maybe from 2007. Okay. In 2007, I organized international summer school in Finland, and many international students, they participated in this course, and we demonstrated this system also. And here in this picture you can see all these are the international students from different European countries, and here I am in the white shirt who is demonstrating this single passenger car to the students also. So, now here I mean you can get the idea that let us say in the developed countries how the education system work and how the students and the community they get integrated with each other for improving their knowledge, learning on different technology. So, here based on your academic background, you may develop some proposal or maybe some research work or maybe project work with the help of your students on some of the components also. Now, here let us say I explained from the sustainable energy technology point of view. Now, we will come on the machine learning side. So, how do you think the machine learning techniques can be used for the autonomous operation of such type of system? Do you have any idea on that one? Yes, of course. So, then another thing which I can say that which I missed in this slide, but I am going to take that point in another slides at some point. So, here being in postgraduate level engineers, do you think any special thing is missing here? Yes, there is some special thing which have been missed in this project. What is that? Any idea? So, here what I want to tell you that wind turbine is there, solar photovoltaic panels are there, and of course, we have integrated the grid also, and you can see that every system components having different operational characteristics, correct? They are not having the same voltage current characteristics or any operational characteristics. To operate any system, we need to have some appropriate reference level. So, here in this project or in this block diagram, you might have observed that there is not any appropriate reference level, because when we want to operate such type of system autonomously using control system, machine learning, right? Now, in future most of the control system will operation will be based on machine learning approach or physics learning, that is much more appropriate word nowadays. So, for that we need some reference level. So, that reference level, do you think it is there in this project or in this diagram, let us say? There is not any reference level. Right. So, to operate such type of sustainable energy system in which every component is going to have very different operational characteristics, for that we need to have an appropriate reference level. So, without that going to be a very difficult. So, to understand that, we need to have some reference level, and on this reference level we have to see how the different components are going to be integrated. And I think most of you are from electronics background, what I understood, correct? Am I right? So, now if you have to utilize your electronics background, how you will help me on that one? Now, our objective with this GAN course is to improve our knowledge, okay? To improve our GAN, basically whatever we call it, right? And now for that we have to utilize your background, okay? And all of you are postgraduate, at least above postgraduate level, okay? So, now you have to help me how we will define a reference level and how this reference level we can use for controlling, okay, autonomous operation of this system. Okay. So, now maybe we will take coffee break, and after the coffee break maybe you can do some of your brainstorming and maybe come with some solution that how we have to define the reference level for such type of system, for what purpose? For the autonomous control, and how we can get that autonomous control? The data which we are controlling here, and doing the autonomous decision by using some physics based machine learning techniques. Okay. So, let us have a coffee break now, and after the coffee break we will again start. Okay.